Paper 2, question 6. We're going to see if we can solve this equation, we're between 0 and 2 pi. So let's draw the graph of it. So we're going to have to do sine of x. So quickest way of getting sine, press the trig button, press enter, get sine of x, move outside the bracket, take away 2 lots of cos. So press the trig button twice and you'll get to cos. I'll put 2x, and we're going to try and find out when this thing is equal to 1. So I'm going to press enter. Now we're going to be in radians, and I don't know if I'm graphing in radians and degrees. So if I press menu, choose settings, my graphing angle is in degrees. I need to change my graphing angle to radians. And if I just click OK, that'll change it for within this document, and I get the diagram which I'm looking for. I also want to restrict my attention between 0 and 2 pi and not have too much domain showing. So if I go to menu and I choose my window zoom and my window settings, my x-min could be 0. If I tab down to that, I could just type in 2 pi. So I'll just type in 2, then press the pi button, and then press enter. And I can have the divisions on the axis to be something nice. So let's go for pi divided by 2. I don't know if the y-axis will be good, so I'll just leave them as they stand for the moment, and then press enter, and I get a diagram looking like that. Now I'm looking to find out when this expression is equal to 1, so I'll type in another equation here by pressing the tab key, press the number 1, and it looks as if I've got 3 solutions, although there may be 2 of them in the same place there. Let's go ahead and try and do this. Analyze graph, intersection. I can just go lower bound, upper bound, and then do another one. Analyze graph, intersection, lower bound, upper bound, menu, analyze graph, intersection, lower bound, upper bound. So I've got 0.848, 2.29, 4.71. Now if you want to do this on the calculator page, I'll press Control Dock, go to calculator, and what I want to try and do is I can just use the numerical solve command here. So if I do menu, algebra, numerical solve, and my variables I want to have f1 of x equal to f2 of x, and I want to solve that for values of x. I'm going to have to tell it to restrict its attention between 0 and 2 pi, but I'll do that in a minute. Let's just see what it gives us first of all. So it's working in degrees here because the setting we chose a moment ago was only for the graphing application. So in order to change the calculation for angles here, I need to go to the cog. I go to document settings, and I'll change my angle to radians, and I can click OK. And now when I execute that command again by just pressing enter, it gives me the 0.848, and that 0.848 is the x coordinate of that first point there. Alright, so let's get the other solutions. If I just press up and enter and paste that in, I want to restrict my attention to be greater than 0.848. I can press Control equals, move to that icon there, and do x is greater than 0.848. So if I do 0.85, that's certainly bigger. I get the second solution, that 2.29 is that value there. And we know we've got a couple of solutions possibly along at 4.71. So again, I'm just going to paste in this last statement, and I'm just going to change that limiting value to go looking beyond 2.29. Let's go 2.3, and I get the 4.71. But clearly the point being made here is by having the graph there, you know exactly how many solutions very quickly you should be looking for, and you can then track them down. Now, obviously we've got decimals here. It's unlikely that these will be exact values of pi, and so therefore we're just going to leave them as decimals. To establish anything is an exact value for pi, then what we could do is look at this last one, 4.71. If that 4.71 was a multiple of pi, then let's just say k multiplied by pi, where forever k would equal that value there. So in order to work out what the value of k would be, I would simply get the long decimal and divide it by pi. So let's just do that. I'm just going to get that big long decimal, divide it by pi, and if this works out to be something even plausibly nice, then it might indeed be a nice fraction of pi. So let's just divide that. I get 1.5, which is surprisingly nice. So if I can do menu number, approximate to a fraction, it gives me something looking like that, which doesn't look particularly nice because there may have been rounding errors, and you can see that it wasn't just 1.5, it had all these zeros in here as well. So what you can do is you can reduce the accuracy. Instead of having a 14, maybe reducing it to about 8, and then you get 3/2, or indeed 3 pi by 2. So this now makes me wonder if the others are nice. So I'll go back to the other decimals. There's that one there. I'll divide that one by pi as well, and see if this works out to be a nice fraction. 0.73 doesn't look quite as nice as the previous. Let's just do menu, number, approximate to a fraction, and maybe reduce its accuracy. It's not looking as nice. So my suspicions are that it's only that third solution that's nice, but let's just, for the sake of completion, double check the very first value, that 0.848, and see if that works out to be a nice value of pi. I suspect not. Doesn't look familiar. I'm not going to go any further. So it looks as if we've got a couple of decimals plus something that work out to be rather nice as 3 pi by 2. Not unsurprising because it's actually at a maximum of this curve. That's the blue one. I think we've done enough. We're done.